Yeah, thank you for the lovely introduction and welcome. I know it's tough to get up on Saturday morning. I've been guilty of that myself. I'll give a minute or two for people to settle in. I'll just start with the agenda that I have today. This used to be basically a half a day workshop that I'm trying to compress into a less than an hour talk. So I'll see how I do that. Because when you start talking about multi-agent system, and I can talk about agents for a couple of hours, forget about multi-agents. If you ask me to talk about multi-agents, add about 1 or 2 days to that. Now I have to do everything in 1 hour, so it's going to be a challenge for me. But the way I have structured this talk is that we'll start with the evolution of AI because we want to understand how we got to this point of AI agents and what is it beyond. Then we start understanding how AI agents, before we even talk about multi-agent systems, we want to talk about what an agent is and how is it different from other programs. Then we go into multi-agent systems. We understand what they are, why, when, how to use it, etc., etc. We talk about architecture patterns. We'll talk about a couple of common patterns. Of course, there are tons and tons of architecture patterns. I saw some typos here, apologies. We talk about communication between communication between agents, communication between various tools. Finally, we touch upon, depending on how we do on time, we'll touch upon certain aspects of deployment, security, compliance, etc., etc. Okay, so let's start with evolution of AI. Okay, so in the beginning, we had these traditional AI systems, right, which were basically rule-based systems, human-coded the rules. For those old enough to remember, there was a language called Prolog, which technically still exists. Nobody uses it. But back in late 80s, it was like very popular because it was supposed to be the foundation of the next thinking machine. And the Japanese had that fifth generation system project where they're going to use Prolog, rule-based systems, and unfortunately ended up with complete disaster. That's another issue. But that's where we start. Then we enter into the era of machine learning because we understand that real life is way too complex for humans to understand. So we really cannot have rules that will cover most of them. But what we have, especially with the invention of internet, is a lot of data. So rather than we coding the rule, why don't we just learn that data, learn the rules from the data? So we come into machine learning, predictions, recommendations, etc. If you go to Netflix, Amazon, you will see recommended books, recommended items, recommended movies, etc., etc. From there, the big new generative AI made infamous by ChatGPT, Claude, etc., etc. So we now go into generative, where machine learning is a passive system, right? You react to it. You react to a user input, whereas generative AI is more of an active system. Now we are actually creating the content, right? Of course, no technology is perfect, so there are hallucinations, etc. But generative AI still creates contents. We don't really take any actions on that. I mean, at least the system doesn't take any action on it. So now we move from generative AI to agentic AI. We say, well, we can reason, think, whatever you like to call it, but that's not good enough. We want to take actions based on our research or our capability to think. So this is where agentic AI comes. And it's a little bit risky because so far we have not been taking any actions, right? Even with generative AI, there is a medium risk involved in the sense that you could have wrong answers, hallucinations, but still no action. With AI agents, we now go into a little bit of a dangerous territory because AI might take an action which may be wrong or which may be something that humans would not have done or should not have done. And our ultimate North Star is to go to artificial general intelligence, AGI, which is both exciting and scary, but we are not there yet. I don't know whether that's for good or not, but we are not there yet. Okay, so we'll talk about AI agents, right? Before we understand multi-agent systems, we want to talk about what an AI agent is. That's the textbook definition of AI agent, right? But very simple terms, AI agents will give you a goal, and it makes a decision, it plans, it executes them, ideally with minimum human intervention. So that's what an AI agent is. And AI agent consists of a couple of components, right? So you have perception. It perceives the outside world, right? Based on that perception, there's an autonomy. It automatically takes a decision. It has some kind of reasoning capacity, reasoning based on past data, training, models, etc., etc. And it reasons that, and then it takes some actions, right? And once it takes an action, it receives the output of that action and it kind of learns from it. So when you're training model reinforcement learning, that's basically what you're doing. You're rewarding the positive actions, reinforcing the learning behavior. The model eventually, if you train it for sufficiently long amount of time with sufficient data, learns. So we now have a learning capability. And as we use more and more AI agents, as we use ChatGPT, you would see that progressively the technology improves. So there is this loop, right? Think, act, learn from it, observe, and feed it back and continue. So observance is what were basically the actions, and then continue the cycle, incorporate the learnings. So this is what an AI agent is. So far, we are still talking about a single AI agent. What are the components of AI agents? The brain of AI agents is LLMs, like large language models, ChatGPT, Claude, or you can have a custom model that you can fine-tune from one of the open source models. Facebook has Llama. I think Mistral also has an open source model. I forgot what they call it, but there are multiple ones. So provides reasoning, language understanding, generation capability. You also have memory. Agent should remember what happened, right? So there's a context, there's past interaction, there is technologies like chain of thought. So if you really look at ChatGPT, you ask a question, it will give you an answer. Then you can ask a follow-up question, okay, change that. It remembers that interaction in a session, so it has memory. There's an execution because you're talking about, you're taking some action, so there is some kind of external tools or functions that you're going to call for actions. There's a step of planning and reasoning. This is particularly important for multi-agents because you're going to plan, okay, I would take some action, I want to achieve something. There are intermediate steps that I need to do. So you break a complex task in multiple steps, and you have the perception, right? Mechanism to receive input from the users, also some observability learning behavior. I should be able to learn and incorporate that learnings back. So that's essentially broadly the components of AI agents. There are tons and tons of frameworks to build AI agents. I particularly chose some small number of open source because if you really look at frameworks, there's a new framework pretty much coming every day, and there are a lot of open source and commercial ones. LangChain is by far the most popular one. It has a lot of tooling for building applications with agents, chains, memory, etc. It provides out-of-the-box integration for various models. Then you have Llama, which is a little bit more specialized for data ingestion, retrieving, RAG. RAG is retrieval augmented generation. Basically, when you have a query, it can, through the internet or external sources, fact check and provide. If you really look at a website called perplexity.com, which is basically the AI, Google's replacement, etc., RAG is the technology that it's actually built in the sense that it will give you an answer. I use it a lot and I love it a lot. It gives you an answer, but the most important part is it gives you the context. Like this is the website from where I took. So you actually can go to the website and verify. That's RAG, retrieval augmented generation. Crew AI, another framework, focuses on multi-agents. Then you have LangGraph, which is basically an extension for LangChain for more stateful and cyclic flows. I mean, managing states in a distributed systems, as it is for anybody who has worked in distributed systems, is a big challenge, right? Because you have partial failures and you want to recover, and states are hard to recover. So you have LangGraph, and then you have a visual no-code automation platform, N-Cross-8, N-Cross-N, N8N. It's actually a little bit tricky because for certain use cases, it can build these agents very fast, but if you have more complex, more specialized one, it would fail in that. So it's a great starting point to play around. Probably not so good if you have specialized needs. So these are the various AI agents. Now that we understand AI agents, we move to multi-agent systems. What are multi-agent systems? So we start talking about multi-agent systems. That's the textbook definition. As we would expect, there are multiple agents that cooperate, interact with each other in a shared environment that has a common objective. So essentially, you would basically take a goal, you would break it into steps. It's a specialized network. There are various architectures. We'll talk about a couple of common architectures for multi-agent systems a little later on. And multi-agent systems have a massive potential to transform complex business procedures. They can analyze the market, supply chains, etc., driving cost. There are some statistics they can add trillions of dollars to global economy that you would expect. But I was actually, after I prepared the slide, that's why this information is not on the slide, I was talking to a friend of mine who works at Facebook. And he says the way Facebook is operating these days, in earlier days, I would say I need 4 headcounts. I need 4 employees to work. In the new modern world, I would say I need 2 employees and 4 agents. So now agent is an entity. I wouldn't exactly say replacing a human, but kind of complementing humans, that you will have more and more use of agents that would be working together. And we'll talk a little bit about MCP and A2A protocols a little later on, but we envision a world. In fact, Facebook's vision is, and I used to work for Facebook. I'm not doing marketing for Facebook, but I'm just letting you know how they think about it. That each one of us will have an agent, and the agent will interact with the outside world. In fact, there are browsers. Perplexity has a browser like Comet. I think ChatGPT also is building a browser. That gone are the days when we go and search on the internet. We will have agents that we can delegate the task, and agents would do whatever we want to do. For example, I might have a personal agent say, I want to plan a date with my wife, and that's all. It knows my preferences. I need this kind of food. I need Mediterranean food. I like kebab. It knows my schedule. It has access to my calendar. It can go look around all the restaurants. It picks up a time from my calendar. And to do that, it will need to talk to other agents, because there'll be some agent that is representing my calendar. Restaurants might have their own agents. So these agents would negotiate with each other. The same thing, you can plan a vacation. So I say, well, I want to go to a vacation in Santorini. I've never been there. I would love to. So that's it. My agent would say, oh, this is the calendar. Let me find a 3-day spot or 4 days, something like that, that is available. Then I'm going to go and book an air ticket. I'm going to book an hotel. I know my preferences. And in order to do that, it will talk to other agents. Those agents may not be owned by me. They might be owned by travel companies like Priceline or Expedia or whatever, these travel agencies. And they will communicate with each other through their protocols, MCP or A2A, that we are going to talk about later on. So that's the kind of new world we are entering. You know, when you look at the evolution, first of all, internet was basically nothing but we go to internet, a board for information. Then we entered into like devices. Our devices talk to each other. Now what we have is we are moving to the next abstraction, where we have each one of us will have our agents. And if I want to talk to you, my agent is basically going to talk to your agent. That's the kind of new world that we are moving into. Okay, so what are the characteristics of these agents? One of the characteristics is decentralized control. When we go into the architecture, we'll talk a little bit more about decentralized, but essentially, as the name suggests, there is no single controlling entity, right? Each agent kind of has a limited viewpoint. Its behavior will depend on interaction with other agents. Those agents may not be part of the same system. I think I gave an example of vacation, right? My agent just deals with vacation, but in order to book hotels, it cannot do it on its own. It has to talk to other agents. Those agents are owned by the hotel or the travel agency or whatever. Designed for complexity. If it's not complex, why would I have multiple agents? I need multiple agents because my problem is so complex that it cannot be handled by a single agent. So distributed problems, complex for this, too complex for a single agent. They all operate in shared environment because they need to have the same context, they need to have the same memory, etc., etc. So there are shared resources, shared environment. Then they communicate with each other, they cooperate, they conflict, they compete. In fact, I was just trying to think on my flight, what are the scenarios that agents would compete? And I think one of the ways in which agents can compete is basically auctioning, right? If you go in an auction, how does auctioning work? People compete with each other. They kind of negotiate, I want to buy this painting for 1 million. The other person says, no, 1.1 million. The other person says, no, 1.2 million. You do the same when you pitch your startup to VCs. In a way, there's a negotiation process going on. And I think there's going to be a future, I think so, where what we will have is this negotiation process might not be done by humans. Humans might just give a broad level goal to an agent, and the agent would negotiate, especially in problems like supply chain. right? I want to build something. I need some iron, I need some screws, I need some hardware. Where do I get it from? So it will try to negotiate around multiple agents in the system. I need this, I'm willing to pay this, would you buy it? This negotiation process would happen. So there's going to be communication, competition between agents, because there are multiple buyers I can buy from. They might be bidding, buy it from us, we'll give you 10% discount. The other person says, no, I'm going to give you 15% discount, so on. So there are advantages of multi-agent systems. Let's try to understand what they are. Solving distributed problems. I mean, when the problem is too complex, the resources, expertise is distributed. In fact, multi-agent systems, like pretty much any concept, we have been using it in some form or another. I'm not from here, so I don't know how healthcare kind of works in Greece, but in States, you have a problem, what do? You first go to a general physician who would diagnose and say, okay, you have a problem with your heart, so I'm going to refer you to a heart specialist. The heart specialist would look at your medical history. He can look at your medical history from all other physicians. They have a network. I once had some high sugar problems, so the doctor referred me to a dietitian. She also referred me to a psychiatrist. She also, in a way, that's a multi-agent system, except that these are not agents, but they are humans. But it's the same thing. You have a complex problem. Each person has its own area of specialization. In order to tackle this problem, multiple peoples have to work. Now we are going into a world where instead of humans, these are agents. But the problem still remains the same, that one person cannot really know everything. So you need expertise. Scalability. Yesterday I was giving a talk on microservices monolith. I mean, why are we talking about all of this? Scalability. You can't really, it's difficult to change one monolithic system. So easier to add more agents as the problem goes more complex, as the demand, you have more robustness and reliability. One of the disadvantage of distributed systems is you have partial failure. Even if some of the agents might fail, you can still operate. The same thing. Other agents can take if the particular agents would fail. That's advantage of a multi-agent system, especially in mission-critical applications. Modeling complex system. Real life is modeling. You have several components working together. So multi-agent systems can model that. Speed and efficiency. You would expect that. You can parallelize. You can have a problem broken into 10 parts. Then each one of those 10 parts be solved by different agents. They can scale and up and down. So you have these advantages. You also have disadvantages, right? You're talking about multi-agent systems. Now you have increased complexity. Everything is distributed. I think that line got copied from the previous slide. Sorry, I'll fix it later on. But you have increased complexity. Now you have to deal with shared memory. You have to deal with shared resources. You have more communication overhead, communication bottlenecks between this one that will increase the latency, overhead, etc. You now have to coordinate. It's like running an organization. You're doing it yourself. You can just do whatever you want. But the moment you run a company, you now need HR. You now need legal. You need a whole lot of things. You need a secretary. You need your personal assistants, right? Because there's a communication overhead. You need project managers, because they have to coordinate between multiple entities. Whereas if I'm running a single person startup, just myself, I don't really need any HR, I don't need any project manager, I don't need. So you now have all of this coordination overhead that comes in. It's very difficult to test a multi-agent system because the number of possible interactions becomes so huge, state space is huge, so testing makes it very hard. It's resource intensive. You have multiple agents, you're running in a cloud, you're paying the bill. So there you go, problem. So the real question is, should I use multi-agent systems? Engineering in part is about making decisions, making trade-offs. So we know that multi-agent systems have advantages. We know multi-agent systems have disadvantages. So what are the guiding factors that we can use, that we can make a decision on? Do I want multi-agents? Do I want single agents? Or I may not even want any agent, right? I can just have a deterministic workflow. A whole lot of problems can be solved. After all, this is how we have been operating to this day anyway. So can you break down the work into independent tasks? Because if the tasks are too dependent, you probably don't want multi-agent system. The communication overhead would be too much. Writing would create bottlenecks. So you have to understand they are primarily reading, analyzing, or writing, etc. That's going to be one of your criteria. When you have multi-agent systems, each agent will deliver it results. So you need to somehow consolidate those results, right? The problem has to be parallelizable. I can break this problem into 10 parts. I can just solve these 10 parts and I can combine the result. For example, when map, reduce, and distributed frameworks came, that's what basically they were doing. You can have a step of map into smaller problems, solve them, shuffle them, combine them, etc. You also have cost increase, you have complexity. So now you have to understand that, okay, fine, I'm getting a parallel processing, I'm getting some advantages in speed, but really, is it worth all the cost increase? So is it worth it? Also another thing is that if one of the advantages we talked about is that agents can work isolated, but what happens if there's a cascading effect? I mean, Amazon had it's not agents, but Amazon had a outage few weeks back. One system failed. It eventually ended up 5 or 6 systems, the cascading failure, and multiple systems failed. So you really don't want that kind of issue in multi-agent systems. Now, we know that we'll talk a little bit about certain architecture. So we know we have multi-agent systems, right? So we'll talk a little bit about what kind of architectures we use. I'll just pick 2 or 3 more common ones because there are tons of them. And in real life, you actually won't use any one of these architectures directly, but it's actually a little bit of a mix and match. So each architecture has its pros and cons. In real life, looking at your problem, you might have multiple systems using multiple architecture, all combining together. We call it hybrid architecture. The central architecture, right? You have one person, and then that kind of coordinates everything across multiple agents. I gave an example of US healthcare. You have a general physician, your family physician, and he's the one who's basically coordinating between, okay, you have a heart problem, go to heart specialist, you have a lung problem, go to lung specialist. He's the one who's kind of coordinating between all of these specialists. A heart specialist probably might not talk to lung specialist. They can see the results, but generally it's less likely. It's your general physicians who coordinate. So that's central organized architecture. Another one is decentralized, peer-to-peer architectures, right? We don't really have any central entity. We have multiple agents, like this is an HR system that I picked up an example, payroll, 401k, which is basically retirement plan, tax, etc. They all talk to each other. There is no single entity. I'll go a little fast because I think I'm running out of time here. Then you have multi-level architecture, right? Typically how organizations work. Sorry. I think I went too fast, yeah. Typically how an organization works, you have a VP of engineering, he passes on, he has 4 directors reporting, 4 directors might have 4 teams. So you have the chief coordinator, then you have the team leads, and then you have multiple agents working under him. So imagine you replace an organization of humans with organization of agents. Everything else stays the same. So that's an example of multi-level architecture. We have pros and cons. Hybrid basically is a mix and match of multiple ones. It generally tends to be very complex, coordination complexity. So we have different dimensions, efficiency, failure resilience. Centralized one obviously will be poor because it's a single point of failure. Decentralized will have excellent. Hierarchical is kind of moderate. It's fairly simple. In the interest of time, I won't go into details of all of them. But you would imagine that simple, centralized is simple, decentralized is more resilient, but it does local minima, local optimizations, etc., etc. So let's talk a little bit about communication. We basically have 2 protocols, A2A and MCP. We'll first talk about MCP. What is an MCP? Model Context Protocol. We know that our agents will call tools. Tools will do the action. Agents itself don't do an action. How do the agents talk to tools? Well, they use a protocol called Model Context Protocol. Okay, slides are getting mixed up, sorry. So it's a language model plugin, what tools are available, what data, how to call them, what they return. Essentially, think of it as USB. You have one USB. I have the USB here that can talk to my headphone, that is display, etc., etc. We'll see some examples. There are 2 examples for MCP. There's a 2-step process. One, when I have multiple tools, I have basically a discovery phase where I can go and discover what tools I have, what capabilities I have. And then based on my problem, I will invoke the particular tool. So this is the first part of discovery. I'll have some examples here. So discovery method, list me tools. Says, well, here are the tools I have. I have search doc, search is a doc. This is the schema, etc., etc. So this is the tool discovery phase. I want to understand what the capability of my system is. Then based on the problem, I reason, I break it into steps, and I say, okay, call me this tool. So that's the second tool. So now it's a call search document. I want to understand query revenue, etc. If you have used Chat GPT Python packages, you would see you're kind of doing the same thing, right? You basically programmatically invoke Chat GPT, and it will give you an answer. So there's a tool called. And MCP use cases is, think of it as a USB. There are a lot of examples, like you can talk to code assistants that are connected to file system, Git, CI/CD, linters, data analysis. Data is a big application area in all of these multi-agents, especially the financial people. I want to understand, I want to make an investment decision. I'm talking about billions of dollars of investment. Go search the internet, find out everything about, say, Tesla. Today is a Tesla shareholder meeting. I think Musk has $1 trillion pay package. Some debate is happening around that, or some voting or something like that. So I want to understand how it impacts the share prices. Customer service, fetch CRM, fetch data, create support tickets, knowledge assistance, etc., etc. So, and then you have like workflows where you have Notion, knowledge management, Jira, Slack, right? In good old days, we have this, like, I can create a ticket, then it gets linked up to my version control system, so I can see when the ticket was resolved, with git commit ID was it resolved, I can click on it. So there's an interconnected network of how the knowledge is managed, and speed and efficiency comes up with such things. You become very efficient. All good about MCP, but the point to remember is MCP is a communication tool between the agent and the tool. Now, what about agent-to-agent communication, which is different? That requires a different protocol, and the reason why it requires a different protocol is because tool use is deterministic. Agent is non-deterministic. For the same problem, agents might give you a different solution. So a deterministic framework is not going to work very well for a non-deterministic one. That is the reason why we need a separate protocol. And of course, there are history. MCP is from Anthropic. A2A came from Google. So corporations try to push their own standards. So there's a corporate rivalry. Anyway, so A2A protocol. A2A protocol basically allows agent to communicate securely. That's the textbook division, and exchange information. It's basically an open source project. I think Google started it, and then it has partners in 2025. And so as I said, MCP is agents to tool, and A2A is agent to agent. Okay. So now I would go about, I have this nice diagram. Is it visible? A little bit blurry. That's fine. But essentially, we have these agents, and agents talk to each other using A2A, and then they talk to the tools using MCP. So what are the characteristics of A2A? We saw what the characteristics of MCP was. It has a two-step process, discovery, tool use. A2A has something similar. So collaborate in a natural, unstructured way, because agents are non-deterministic, right? Natural language is basically one of the ways in which mostly we interact. Of course, natural language is not a good way because it's fundamentally very ambiguous. In the research community, they are trying to come up with a semi-natural way, in the sense there is a little bit more determinism. So it's not going to be pure English. It's going to be a little more less vague, I would say, but still open enough, because technically you don't really want a very restricted schema for agents to talk to each other. If you want that, then why bother with an A2A protocol? You might as well use a REST call, which is completely structured. So that's one characteristics. It obviously has to support enterprise-grade authentication, authorization, etc. Maybe I'm sidestepping a little bit, but multi-agent world is going to be, we obviously cannot predict the future, but multi-agent world is going to be very complex world. I think there's a startup in Silicon Valley by the former Twitter CEO, and that startup is called Parallel Web Systems. And parallel web means there is a web made for the humans, which is the web we are aware of, and then there is a web which is made for the agents. And agents would communicate. And, in good old days, when someone came up with the REST protocol, it was like, why the hell would somebody communicate with REST? Because we had this notion that internet is meant to be consumed by humans. So you have HTML, which is human rendered language. And then we realized that it's actually going to be confused by services, by tools. So it doesn't really have to be human renderable. Then we have a more general XML and then JSON as more structured, but more general, more a generalized language for communication. So we are kind of doing the same thing with web. I gave an example about vacation planning, right? When these agents would talk to each other, do they really care about English and website and presentations, etc.? No. There's going to be a probably, maybe, completely different web, which is going to be, this is the web meant for humans, like we have HTML pages, and this is the web meant for programmatic calls, which is the REST APIs we have. Fundamentally, they work the same way, but one gives an information in a human consumable way, other one is gives you an information in a machine consumable way. Similarly, we will have a web where we will have agents, and this web will basically give you information in agent consumable or machine readable way as opposed to human way. That's the whole idea of parallel web. And we will, like I said, kind of the Facebook vision. Different people have different visions, right? But essentially, if you unify all of these, the common thing that I can make out whether you is that we will have agents that would communicate with each other. We humans won't, for good or for bad, not directly communicate with systems or humans, but we will have these agents. Our agents would do auctioning for us, our agents would book restaurants, our agents would plan vacations, our agents would do household work, and you see a lot of startups kind of doing the same thing. They can read your calendar, they can read your messages, they plan your day. This is how your day is going to be like, right? So their promises makes you more productive. Whether it actually does or not, well, time would answer that question. Anyway, so support for quick task and long-running tasks. We could have something like systems like Snowflake, etc., where we have long-running tasks. We can just delegate, takes a couple of hours, like data analysis, research, the financial analyst would do, right? They're not going to get an answer immediately. It will search the web, it will basically compile all the financial resources, etc., give you back the answer. It's built on existing standards, so we don't really want new standards. And it has what is called Agents Card, which basically is, remember we talked about discovery in MCP. So it's basically the A2A equivalent of discovery, because when agents talk to each other, they need to know what is the capability. Like a general physician needs to know this person is a heart specialist, this person is a lung specialist, this person is like EMT. So depending on the problem, they can be triaged. So agents advertise their capability using Agents Card, okay? We are talking about, okay, I have time, good enough. Yeah, so now we compare different protocols. The key important thing, agent to agent, agent to resource, and REST is like a generalized any to any. Then we have various characteristics like autonomy. Agent to agent is a little bit of a negotiations because agents are non-deterministic. Tool is more of a command. This is the tool has to do. Tool doesn't think, tool doesn't negotiate, right? I have taken a decision, I want you to do this. That's it. REST works the same way, request response, give a command to that. A2A, because we are talking about multi-agents, so it has to be multi-agents workflow, whereas MCP and REST, MCP is single agent because technically an agent will call a tool, not the agents might call other agents, but the tool will still be invoked by a single agent. And REST is kind of generalized. These are all new stuff. Every now and then, anybody who has been following AI, they know that there is an overwhelming information, new stuff coming. So all these standards are emerging. At this point, we really don't know whether these are the standards that we'll use for future or not. We really don't know. And AI world, especially multi-agents AI world, sort of is complex. We'll have challenges with scaling. We'll have challenge with orchestration. So there's a complexity aspect of it. MCP, the more non-determinism the system has, the more you'll have like determining, the more you'll have guards on action. Should I do this? Should I not do that? More you have to do the validation, more you have to do the orchestration. That is why anything that involves agent generally will have high complexity, and agent to agent will have the most high complexity, whereas agent to tool generally will have less complexity in terms of implementation, but they still will have additional guards, and we'll talk about some safety guards, input validation, output validation a little later on, but you need that because you want to make sure these actions are correct. In fact, there has been some examples. Everybody loves a Replit. They tried to create the project from Replit, and I think something happened and Replit went to version control and deleted 100, 200 files. And I don't know whether they were able to basically recover from that disaster. But hey, people make mistakes, humans make mistakes, tools can make mistakes. The problem is if you have a human, you can throw that human to jail. You can't really throw an agent to jail. So you really have to be very careful with that. Okay, so we have talked about basically agents and communication. Now we touch upon aspects like deploy and more of DevOpsy aspects like deployment, security, compliance, etc., etc. So agent world is a new world. We want to have appropriate security checks. We want to have appropriate guards. So we take certain principles that are good guiding principles for us to build these systems in practice. Generally, we want to do like strip down containers, only essential dependencies, right? The more dependencies you have, the more attack surface you have. We already have seen a lot of security breaches, and you'll have agents, and you probably will have computer viruses disguised as malicious agents. You're going to have all of those problems. So you really want to protect yourself. Proper authorization and access control. We have this problem even in services world, right? Proper IAM permissions have to be set up. So you always want to do the same thing with agents. Agents are more dangerous because they are committing actions, right? So you always want to have the least privilege access at all times. Micro-segmentation. Essentially, this applies to network. Segment the network based on agent roles, etc. So you really don't have flat network. You want to enforce proper segmentations, like this network deals with these issues. It's isolated, etc., etc. Identity. Every agent should have its identity because you're talking about IAM. You're talking about giving a permission. So agents need to have their own identity. Secure communications. Especially with outsiders outside your system, you want to have secure communications, data encryption, compliance, GDPR. There's a California Privacy Act. I forgot the full form of it, but it's like California Privacy Act, something, something. Collect the minimum information required only for intended purpose. It's annoying that when I use Google from my hotel, it always asks, do you consent? Yes, yes. You never have to do it in States. I think the Europeans are much more cautious about compliance aspect of it. So I have to click a lot of yes, but nevertheless. Yeah, so we have data privacy laws here. HIPAA is basically a US specific regulation for healthcare. I'm sure Europe has something similar, but compliance is a big aspect in healthcare, in insurance, etc. Financial trading, there are strict regulations inside insider trading, etc. So you can't manipulate the market, money laundering, etc. Technology can be used in a negative aspects also. We want to be careful. You don't want to get sued for racial discrimination and stuff like that. So you need to have bias. I think Google got a lot of criticism that I think they kind of, I don't exactly remember what happened, but you make certain queries when Google came out with their Gemini model. I think now they have improved quite a lot, but when they came out, it basically was biased towards showing certain races in a rather negative way, and there was a lot of criticism and reputational damage to Google. So you really don't want to get into that. Very big issue here, intellectual property preservation. We are training models on these data, but where is the data coming from? Is it a copyrighted data? There is a lawsuit. I don't know how many lawsuits even ChatGPT has that, when you're going to these internet, a lot of this data is copyrighted, and you have these robots that scrap the data and then they train. Technically, it's a violation because you haven't taken the consent or you haven't compensated the person who created that content. Facebook had a similar lawsuit. They used this libgenesis for their llama model, but libgenesis is all copyrighted material. So you really cannot do that without consent of the person who created it. Security, big task. You're taking actions. Zero trust models. Models communicate with each other. No agent can be inherently trusty. So your system has to be designed using zero trust technologies. Credentials have to be very secure. These are like general security issues. You even have the same problem with services, right? You don't hard code. It's funny that how many people keep their passwords and check in the code in GitHub, sometimes even in public repository, and there are these tools that hacker use. They just scrap and get these credentials and then hack your systems, etc. So you need to have proper secret management. Input validation, output validation. You need to have guards that would validate and sanitize all inputs. Similarly, validation on the output before you pass, especially when you call the tools for action, you want to make sure that this is actually the right thing to do, data minimization. Share the minimum amount of data to complete necessary tasks, because you might run into issues like you are exposing excessive data, the model might be confused, you might have security implications, etc., etc. Common mistakes to avoid. Okay. Oh, I'm almost out of time. Always start simple. Do not over-engineer. Always, things are not going to be reliable in a distributed systems. Ignoring S cases. Poor prompt. If you garbage in, garbage out is a very famous quote, right? If you give vague inputs, you're going to get vague answers. So you need to have proper input, well-defined problem. In fact, this is a drawback of natural language, that inherently natural language is kind of vague by definition. Inadequate memory management, neglecting performance. Performance is a very big aspect. I'm almost out of time, so I'm just write the summary. Agentic systems are next evolution. We know how automated agents talk. They talk to each other. They coordinate with each other, achieve a goal. Multi-agents is multiple agents working together. Autonomous single agents working together. There are pros and cons of multi-agents. We talked about it, when we should use them, when we should not use them. There are protocols for communications and external tools. With that questions, I actually don't know how much time I have. I don't want to eat up in the next person's time. So I don't know. If you have a quick question, I can answer. But if there are long questions, I'm hanging around, so I'm happy to answer any other.
Yeah, because we need to follow the schedule. You can reach out, Nikhil,
Yeah.
right here, or he will be around for the mentor
I'm here the whole
session.
day.
Yeah.
And
Thank you very much.
Yeah, contact information is there, so feel free to email me, ping me, whatever.